Hello everyone, we are here to present our midterm project, that is content-based image retrieval system using color histogram. Me and my teammates are here to present the project and explain the demo as well. Now I'm going to start with the background introduction. In today's digital world, images are everywhere, but text-based search often fails due to missing or incomplete tags. Our project tackles this with CBIR system that searches using image features like color distribution instead of text. This enables more accurate and practical applications in image search engines, product recommendations, and digital asset management, and etc. And here is the problem statement. With the growth of digital images, text-based search is often inefficient. Content-based image retrieval overcomes this by analyzing visual features like color, texture, and shape. Our project implements a CBIR system using a 6-bit color histogram to efficiently retrieve visually similar images with greater accuracy. And this is important because this system uses visual features like color, and this automatically retrieves the similar images, and this is very helpful. And let's go with the literature review. The literature on CBIR spans from simple color histogram to deep CNN features. Color histograms are efficient but lose spatial information. Two very different images can look similar if colors match. Texture and shape descriptors add discrimination but cost more computation. Deep features capture semantic similarity, but they need large scale label data. For this project, we start with classic histogram approach, and the strength here is histogram based approaches remain effective for fast and scalable retrieval. And here is the methodology we used for our project. Our workflow is modular. First, we set up a reproducible workspace. Every image is converted to a 6-bit uh, color-coded representation using RGB2CC function, and then summarized into a normalized histogram with 64 bins using getHistCounts. And all histograms are stacked into dbmat. For retrieval, we compute Euclidean distances between the query histogram and each row in DB. Our main CBIR script that handles query selection, feature extraction, distance computation, ranking, and display. And here is my teammate to continue.
Hello, this is Karthik. I'm next going to talk about method, key functions, and design choices, where RGB26 is used for the RGB 6-bit code from 0 to 63, where each function plays a key role. GetHistCount ensures the features of the normalizing and comparability. For the distance we choose, because the straightforward and work where this equidien will be used in these normalized forms. Coming to the distance we choose for the Euclidean, the straightforwardness will be work for the normalized histograms, where finally we use CBIRM.m ties together plays a key role for the query images. Distance are computed from the results ranked from top 20 displayed, such that this will be used for the functions and the key choices. We're coming to the next, we are going for the results. uh, we're coming for the results. We have the query image like 101.jpg, which will be used for the top 20 retrieval conformation for the color histograms captured by the board similarities. We're coming from the observations. We will be getting like a two type of observations. One is a good image and one is another one is a bad match. We're coming to the good matches. We'll use like images with the similar dominant colors appear from the top rank, which will be used like a simple it will be crystal clear, which will be suited for the same thing. Where coming for the bad matches, it is a semantically different but color similars of image will be retrieved. That will be not the image color will be completely different, and which will be not suited for the sample images. Where these results will be used for the sample retribution and other type of data. The main key role will be used for these results is CBIR.M will be used. Coming to results and the evaluation matrix, there are three type of potential metrics. One is precision at the rate of k, another one is recall at the rate of k, and another one is the F1 score. Where coming to the precision at the rate of k reveals that the images in the top level of k. Where for the like that, if for a labeled data set we would be compute the precision recall at the top k plus F1 scores. For example, if 8 of the top 10 are revealed, if the precision will be at the rate of 10, it is equals to 0.8. Where coming to the recall at the rate of k is the fraction of uh, reviewed. Where coming to that, if you want to reveal these recall at the rate of k, we use the visual representations and the images. Where coming to the F1 score, it will be balancing the precision and recall. The both will be used for this F1 score. The current database set will be used for unlabeled, so the metrics will be different. Coming to the future work could be group of images by the category labels will be computed at proper reveal metrics. Let's come to the conclusion. In the conclusion, we have learned about the color histogram effects, but limited. In this color histogram, we use like a CBIR dot frameworks. Works will be correctly demonstrated for the basic and image retrieval colors. It is a solid foundation but has a limitations, no specific context and high specific to the color similarity without semantics. Coming to future work should be incorporate more descriptive features like textual or deep learning embedded systems. This results for the feedback of the refined results. Where coming to our improvements, we need to add texture, shapes, and CNN features for the next feedback. Let's go for the references. Coming to the references, we use like a SWAM at the SWAM and Ballad color index, which is IJCV 1991, which is used for the color indexes. Where coming the We're coming to the MATLAB documentation, image processing toolbox, and computer vision toolbox. MATWork will be used for the references. Next will be continued with our friend.
Yeah, now let's walk through the code. This RGB file right here, it quantizes each RGB channel to 2 bits and combines them into a single 6-bit index per pixel, giving 64 bits total. Generally, this gives us a compact, fast feature. Basics for CBIR, it deterministic and efficient, perfect for baseline system. Now let's go to the get his count script. The purpose of this is to build and normalize the 64-bit histogram. Generally, the purpose of this is to count how many pixels fall into each 6-bit code, that is 6 to 63, 0 to 63, then normalizes so the vector sums is equal to 1 exactly. And without normalization, larger images would dominate distances. With normalization, two copies of the same picture at different resolutions produce the same feature. So this part resolves that. And now let's go to the main database script right here. The purpose of this is to iterate through the dataset and extract each image's normalized histogram and stacks them into a 100 into 64 matrix DB saved to the disk. Here we see the dbmat file in the meta folder. This database file, if we run this code, we get this db.mat, and where we can see all the distances in the yeah, right here in the workspace we can see the DB file. After we click that, we get a matrix right here. Yeah, here is the matrix that I talked about. Now, if we see the get distance script right here, this returns a column vector of Euclidean distances. Mainly it involves that concept. And after that, now let's move on to our main file, that is CBIR. Yeah, this is the main script. The script is the entry point of our image retrieved system. It guides the entire process from selecting a query image to displaying the final results. Now first, when we execute the script, the MATLAB prompts us to select a query image from our dataset. For grading assistance, we use 101 JPG as our query image. This image will be used to compare against the entire database. Like generally, this calls two functions, mainly RGB and the build database we talked before. And here are the results that we get after running the code, and the script that loads database also included in this, and all the images in the it takes it from the db.mat where it's saved in the mat folder. The ranking system ensures that the most visualizing similar images appear first. The ranking distance is the another concept involved in this. And now, as we see here, the script visualizes the result. It shows the query image on the top, followed by the top 20 most similar images in a 5 into 4 grid. Each image's original file name is displayed as the title. Right, we can see here. We also have the names about the pictures as well. As I already said, that ranking ensures that the most visually similar images appear first, right? We can see here, this is the main query image that we have taken for the examination, and these are the followed next images for that. And also distances.mat and ranking distances.mat is also saved in the meta folder. We can see right here. Yeah, here are the mat files that I talked about. And now let's hop up into the conclusion part. Finally, the script visualizes the result as I showed before. It shows the query image at the top and followed by the 20 most similar images as a grid. And the demonstration shows how the entire CBIR pipeline works, and from features extraction to ranking and visualization is implemented in the MATLAB. As we can see, the results confirm that our system retrieves visually similar images effectively using color histogram based combination, and we see that images with lower similarity scores appear further down the list in the output as well. So thank you for watching this. If you have any questions regarding this, just comment down. Thank you for watching.